today, and I think we're going to bring in Dave, also from Ambassador Labs, also a developer advocate. Love it.
Welcome, Dave.
How's it going? Thanks for having me.
It's great to have you here. So with that, we will add your slides. We'll duck out. Looking forward to your talk.
All right, thanks. So hi, I'm Dave Sudia. I'm going to be talking about how to secure the front door. It was funny when Adidiyong was saying, well, the old model was secure the perimeter and the new model is, trust nothing. We're going to talk about securing the perimeter because that is still important as you go through. It's not zero trust if you let everybody in the door and then stop trusting them. So the agenda for this is who am I? Why am I qualified to tell you about all this? Then we're going to talk about what we're doing in terms of actual concrete steps. What we're trying to achieve. What is Emissary-ingress? We'll talk a bit about that project. What are the goals of this session and non-goals in terms of the concrete things we're going to do? What are some prerequisites that I've already set up? Because for purposes of time, we're going to focus on the specific things we're trying to accomplish with zero trust here. So there are some things I've already set up, but it's important to have that context. And then we're going to go into a demo because I'm a DevOps engineer and I like actually working with code. And so you're going to get to see some stuff roll out live. And then there'll be hopefully some time for Q&A. The only thing that's gone wrong so far today is I had some dental work done last week and my tooth really hurts. So hopefully that means the demo is going to go just fine, but we'll see. So who am I? I'm Dave Sudia. I'm a senior developer advocate at Ambassador Labs. We are the authors of Emissary-ingress and Telepresence in the projects in the CNCF. Before I was at Ambassador Labs, I was an end user. So I've worked at Fanatics, licensed sports merchandise company, Go Spot Check, which was a field data collection tool, and Upchieve.org, which is a nonprofit that provides free online tutoring for low-income high school students in the United States. And I've had various titles and responsibilities at all those, but at all of them, I've really done a lot of, call it DevOps, which is a methodology, not a team, but often the name of a team. Call it the platform team, call it what you will, as the words around this space constantly change. But what brought me to Ambassador Labs was I've been a user of Emissary-ingress for 5 years now, and I love it as a tool and decided to help share that gospel. So why are we doing this particular thing? Why are we securing the perimeter? Well, the start of zero trust is the edge of your system. If you don't secure the perimeter, you're gonna have a lot more problems securing things inside your system. So there are several components to that we are going to get not really going to cover today. Allow denialists, rate limiting, authorization. We're going to talk a bit about authentication today. But fundamental to zero trust is encryption. If you're just sending all your data around in plain text, that is very bad practice. And so the first thing we're going to make sure is that all traffic coming in is encrypted. We don't want any man-in-the-middle attacks between our users and us. And the other thing is a request from an unknown user could be from an attacker. So we should be authenticating our end users. By default, we should be authenticating as much as possible. And then, you might have your homepage that doesn't require people to be logged in to access it. But you should definitely be making exceptions to the rule by unallowing unrequiring authentication on pages rather than by default making things accessible and then only requiring authentication on a few things. I see there are a bunch of questions coming in the chat, so I'm going to go through because it's way off in my peripheral vision, and then at the end I will make sure to get to all the questions. So what are we doing today? As platform engineers, we're going to take on that persona today. We're going to create a single entry point for traffic into the cluster using Emissary-ingress, and that's actually already done. We'll talk about it in the prerequisites. We're going to create TLS certificates using cert-manager. We're going to use those certificates, we're going to use those tools to ensure that all incoming traffic and responses are encrypted. And then we're going to apply basic authentication to all the requests coming in. And I know that basic auth is not generally the thing you should achieve or strive for, but for the purposes of a quick demo today, we'll be doing it with basic. So let's talk a bit about Emissary itself. It's based on Envoy. And Envoy being, one of the graduated, very, very famous CNCF projects, it's based on that for performance reasons. It's based on that for capability and reasons. It's based on that for reasons of velocity of new features. Emissary is Kubernetes native. It's open source. It's a CNCF incubating project. The thing that originally drew me to it is that it offers a decentralized workflow for platform and dev teams. So we're going to talk a bit about that as we look at code today. But what it really allows, when we're talking about zero trust, even within, you shouldn't have zero trust within your internal teams per se, but there are some resources that should be owned, by a centralized team that's really owning the security portions. And then there can be resources that are owned by developer teams who just need to move fast and not worry about that stuff. And one of the things that Emissary-ingress allows for is we have CRDs for managing certificates and their usage and what domains are allowed and that sort of thing that can be owned by a more centralized ops or platform team. And then there are other resources called mappings that are just like, here's how to get traffic to my app, that developer teams can own because then they can configure retries and timeouts and things that a centralized team isn't necessarily going to know about. We'll look at that a bit. The features of Emissary, it supports pretty much every protocol you'd want it to support. It offers advanced load balancing, CORS protection, circuit breaking, and zero downtime reconfiguration. So you can add in a new mapping or a new host or something and not have any interruption to your traffic coming through your cluster. So goals, concrete things we're going to do today. I've already installed an app, the Faces app that Adidiong introduced into my cluster. We're going to first route insecure traffic there using Emissary-ingress just to get a sense of like what is a host, what is a mapping. And we're not going to keep it that way, but again, taking on our platform engineer persona here, we're doing a bit of a POC today, and then we're going to create a TLS certificate using cert-manager's HTTP01 solver for Acme certificates. We're going to get it from LetsEncrypt, so it'll be a production trusted CA certificate. You can also use cert-manager's DNS01 solver for mechanical reasons of all the code that I'm going to use today is in an open source repository that I'm going to provide the link to at the end. You could clone this and actually try it in your own infrastructure if you wanted to. And so for those reasons, you need a lot more secrets and stuff to do DNS solving. So we're going to do HTTP. We're going to attach the certificate to our routing configuration. We're going to confirm then that secure access works. We're going to reroute all insecure traffic to HTTPS so that you cannot send insecure requests anymore. And then we're going to do that basic authentication on all requests from our end users. Non-goals, what we're not doing in this session, but it's not a non-goal for the day, is examine cert-manager in detail. There's a cert-manager talk later today. You should check it out. We're not going to terminate TLS at the app. We're terminating it at Emissary. Your developer shouldn't have to worry about this. The joy of working in this environment, and one of the things that I love the most working as a platform engineer, is empowering my developers to not have to worry about stuff. And so, they can just write their apps, and we're gonna terminate TLS at Emissary right now. But then in the later talk, Linkerd is going to handle mutual TLS between Emissary and the application, and that will make it so that developers just deploy their stuff and you have full TLS all the way down to the application without them having to worry about certificate provisioning and pulling it into the app from a volume or something, right? I'm not going to cover advanced load balancing because, again, we're going to let Linkerd handle it from there. One of the things I really like about Emissary and Linkerd and cert-manager and Player, like all of these tools, is that they're all really purpose-made, and you don't have to adopt all of them at once. When you're figuring out a system, certainly by the time you go to a full production system, you would want full zero trust system in place. But as you're figuring it out, going back to my experience first coming into the Kubernetes ecosystem, it's a lot and it's too much to try to do all at once. And so, the thing I kind of like is you get Emissary in place. Great, we've got traffic coming in now. Okay, now let's look at the service mesh. Okay, now let's look at the policy engine and that sort of thing. And you can kind of incrementally adapt each piece as you're figuring out how you're going to run a Kubernetes-based system. So all that's getting covered in the rest of the sessions. Please stick around. Prereqs for what we're doing today, things I have already done in the environment that we're about to look at. I'll kind of briefly look at the code to do these, but you won't need to wait for them to install. I've created a cluster. I've installed Emissary-ingress. I've installed cert-manager, and I've created cert-manager cluster issuers. Cluster issuers are cert-manager CRDs, custom resource definitions, that tell cert-manager how to acquire certificates. I hope Tim doesn't correct me on this later. I hope I'm getting this right. And a cluster issuer specifically can be used for any namespace in the entire cluster. There are other issuers you can use that are just like namespaced, but for simplicity purposes today, we're doing cluster issuers. I've created them for LetsEncrypt LetsEncrypt's staging server, because it is critical that you test your configuration before attempting to get prod certificates from LetsEncrypt. There have been multiple times in my career where I have very quickly burned through LetsEncrypt's production rate limits and been unable to get certificates for another week. So we're going to check it in staging, and then we will get a production certificate, and then go ahead with the other things we've done. Then what we need to do is create a DNS entry so that we can get a qualified domain coming in that we can get a certificate for. We need to create host and mapping CRDs. We need to get our certificates. And I'll talk about what the host and mappings are as we get there. We're going to configure our host CRD to use that certificate to redirect insecure traffic, and then configure basic auth. So here's kind of a architectural overview, right? I'm going to be making a request from my browser. It's going to go through a CDN. For today's purposes, I'm using Cloudflare, but that is not a critical part of this. That's just where my domain happens to be managed. Those requests are going to reach Emissary. Emissary is going to check to see if it should be listening for requests on that domain by using that host. That host, in turn, is going to use a certificate for TLS handshakes. That certificate was generated by cert-manager. And then Emissary is going to check with the auth service and see if this user is authenticated and should even be able to get into this request. And then it's going to use its map. It will have already used the mapping to create an Envoy configuration that the underlying Envoy then can use to send requests to our service. All right, let's get into the demo. So I am a really big fan of infrastructure as code. It's just how I operate now. So I'm just for context, I'm using Pulumi, and all of this is written in TypeScript because I really like strongly typed things. Makes it easier to write. And you can see that we've already got a provider that is, but all these concepts, if you've used Terraform or anything similar, it should be pretty familiar. We've got a provider for the cluster so that it knows where to install things, what kind of kube configuration to use, and we can just kind of briefly look at these things real quick. So I'm just saying, hey, go look in my kube config for the kube crash cluster. We've got an emissary and cert-manager releases, so we'll just look at one of those real quick. So that basically looks like this is the values I would put into a Helm chart, and the repository to get it from, and the version, and that sort of thing. And then like I said, I've created my cluster issuers. If we come in and look at that, those are a little more complex, but not way more complex. So basically we're saying, and again, this is TypeScript, but it basically all these JavaScript objects just match into what you would read in YAML. It's pretty much a one-to-one conversion. So we're saying in our spec for the cluster issuer, use the LetsEncrypt staging server. It stores a private key that it can look for things in, and it's going to use HTTP01 solving. And then we've got our production cluster issuer down here as well. To get into the real business today, the first thing we're going to do, as I was saying, is create our DNS and host. So I'm going to come into my faces piece here, and I'm going to uncomment my host and DNS objects. And we'll just look at these real quick. So my host is saying, or my DNS is just creating faces.thedevelopment.com in Cloudflare. And I'm referencing the external IP that was created for Emissary earlier when I installed it. And then my host CRD is going to say on the host name, faces.thedevelopment.com, you can listen on that, you can receive requests. And I've got a request policy saying, hey, if you get any insecure requests, just send them through. Because again, for right now, like we're not going to keep this here like this for very long, but for right now, we are just going to let it through just so we can check our configuration. And I'm going to run Pulumi up, which will give me a preview, similar if you've used Terraform. I want to create these two things. I'm going to say yes. All right, there we go. Now, if I try to go to my application, nothing happens. And nothing happens because we haven't told Emissary how to route anything yet. So the next thing we need is some mappings. And again, mappings would be traditionally owned by the development team. They're, okay, we've got our Faces app going out today, and we need to get traffic going to it. So, if they had a Helm chart or a customized directory or something for their application deployment, then they could also put these mappings in. You could control them using, GitOps, and that's kind of how you can get these things out as an application developer. But for today, since I'm controlling everything, it's just here so you can see it. These are very simple mappings. They're just saying, hey, if you get a request on faces.developnik.com, on the root path, send the requests over to the GUI service. And if you get something on /face, send it to the face service. So pretty simple. There's a lot more you can do with mappings. You can do timeouts. You can do retries, like all the things I mentioned earlier. But for today, we're just going to route traffic. So I'm going to do Pulumi up one more time. There's a question of where I can find the code. I'm going to post my slides in as a link in the chat when I'm all done here. And the last slide you'll see is has links to all of this stuff. So I'm going to hit yes. I want to create those two mappings. And I love demos like this because normally the demos I do are just like, look at this code, look at this terminal output. But today I get to show you something that is the output of that code that I just ran. So here is our face service running. You can see mine is not running quite as smoothly as Didiong's because there are things happening in the background that are problematic because I don't have Linkerd installed in my cluster yet, and I don't have Polaris installed yet. So, but here we go. Now, okay, great. We've got our POC is done. We can get traffic getting to a service that we have in our cluster. So now I want to go secure it because, of course, the whole point of today is actually making sure things are secure. So, got our mappings. There is a little bit of a trick here, and this is why I said like the other way to do this is with DNS, which is that cert-manager works natively with Kubernetes ingress objects, CRDs. Emissary, despite the name Emissary-ingress, is not an ingress. And that's because ingresses are kind of limited, especially in terms of that decentralized workflow I was mentioning, right? Like for an ingress, things have to be in the same namespace. The permissions, again, getting to the trust, it's not just about like network trust, right? But it's about like who can create and manage what objects in your cluster. And what we really want is to give, developers access, or the systems that they go through, access to create objects in the namespaces that their applications are in, but we don't want them to be able to create objects necessarily in the namespace that has all of the stuff that is like infrastructure or critical infrastructure, right? So what we want to be able to do is, cert-manager doesn't work completely natively, but it's not that big of a deal because we're just going to kind of hack in here a service and a mapping that say, hey, find any pods that have Acme cert-manager HTTP 01 solver true as a label, and that service will send that through. And then we're going to create a mapping that says if you get anything coming in on any hostname that's .wellknown/Acme challenge, right, then just route it over to that service. And so as cert-manager creates pods on demand to fulfill LetsEncrypt solving requests, we're just going to route that through. So I'm going to create that. And then I'm going to create a staging certificate so that I'm checking that my configuration works. And, this is something that I could have done before in the same way that Ricardo earlier was like, hey, I really want you to know about the registry being deprecated. This is my personal, I really want you to know to make staging certificates first. Don't be me. Don't burn through your production rate limit and not be able to get certificates. So let's come back and uncomment these. And another thing again, if you're not really familiar with infrastructure as code practices, one of the things I really like about this is that I can say, hey, don't try to create this certificate until the service and mapping that I want to make exist. Don't try to create it until that host exists so that, LetsEncrypt is not sitting here pinging us over infrastructure that's not set up to receive those requests yet. So when I run Pulumi up now, it's going to make the service, it's going to make the mapping, and it'll wait until both of those are completely done to try to make the certificate. So let's run include me up. We're going to create 3 things. That is the plan I want. And I'm going to hit yes. All right, now I want to see the status of my certificates. I want to make sure that I actually have a valid one. And look at that, in 8 seconds, ready, true. My certificate is ready and created, and there is a secret, faces the development com staging, that exists for that. So we are all good to go on our things working. So the next thing I want to do then is make my production certificate. So I'm going to uncomment that code block. How do we manage secrets used by applications? There are so many ways to do that. I think I'll address that as we get there. Okay, so, and Guilherme has a great question. If Emissary isn't an ingress, what ingress do we use? So I'm going to run this, and while this is running, then I'm going to show. So it's not an ingress. It is an API gateway. While it's not an official ingress object, what I do want to show real quick is, oh my gosh. Stop trying to help me out. This kind of comes in the end. So what we've done for Emissary is create a load balancer. And so it is the only publicly facing service. So it's a Kubernetes service that then comes into and routes to all of the Emissary ingress pods, which then further route. So it acts as an API gateway. It fulfills all the things you would need out of an ingress. You don't actually need like a separate ingress controller. It just isn't, because it was sort of thinking a bit bigger than what the ingress was. And I'm not trying to like rip on ingresses either, but as an initial object. And the thing I'm really excited about coming up here is the Gateway API, because the Gateway API now takes a lot of these ideas that have been generated by Emissary and other projects over the last several years, and is going to make that sort of the new official thing. But yeah, so it's not like an official ingress object, but it does work exactly as an ingress. So that's a good clarification to get in there. So we created our prod certificate, and let's just double check that that is ready. And yes, it is. Great. Okay, so our certificates are ready. And what we're finally going to do here is we're going to modify now the spec for our host. And nope, not that. The key changes we're making are that we're adding a TLS secret property now, and we're pointing it at that secret, faces the development com, that is where the certificate resides. And then we're changing our request policy from insecure action route to insecure action redirect. So now anything that comes in on HTTP should get redirected to HTTPS, so that we're not allowing any insecure traffic. So let's run that. And we're just going to update that one object. Yes, that's what I want to do. And there we go. So now I should be able to pop right back over to Firefox. And let's first check that HTTPS works. Yes, it does. Fantastic. We're now on a secure connection using a production LetsEncrypt certificate. And if I try to get it on HTTP, I just get redirected right back to HTTPS. I can't, unfortunately, blow up that address bar in my browser, but in case it's too small in the presentation, but I promise you it's now been redirected to HTTPS. So there we go. We now have, with just a couple objects applied, we've got a production certificate from LetsEncrypt, and we've applied it in with just one small change. So the final thing we want to do is authenticate. In this case, like we want to authenticate everything coming in. I'm going to assume that Faces is like an internal tool that we're using to determine if our systems are up or not. It's our internal status page. Oh, that system is down. It's got a frowny face. So I don't want any outside users reaching this. I want to authenticate everything coming in. So the final thing I'm going to do is uncomment this. I just have, these things are just in YAML. It's a service. It is a deployment that's going to deploy a little sample basic authentication service that Emissary can use. And then I'm creating an auth service CRD. That's an Emissary CRD. And that is telling it, reach out to the service that I'm deploying over there, add this path so that it can read, oh, this is something I should be authenticating, because I could have my service choose not to authenticate some paths or whatever, and use these headers for the session. So let's install that. Great, we're going to create those things. And this is the only time we should really have to wait today, if we're waiting for these pods to get created and run. And there we go. Now, if I come back here, see, it tried to refresh, and I am now needing to log in. I don't know. Okay, fine. I guess I'll authenticate. Don't ever use these values. It's username and password. And I can sign in, and now I'm authenticated, and I can access the site again. So that is the steps, the code. Again, I'm going to share the link for that in a moment. Let's come back to our slides. So to sum up, Emissary-ingress becomes the only entry point to the cluster. When we talk about securing the perimeter, you don't want lots of IP addresses to have to monitor. You don't want to have lots of different entry points to have to check the logs and check your CVEs and everything. You just want one place where it comes in. You can monitor logs, you can monitor metrics on that, and make sure that things are going smoothly in the way you want them to. You don't want developers having to create points of entry into your cluster. So we create one entry point. Everything gets routed through that API gateway. All requests not made on an established host, we reject them. Hosts are configured with a trusted certificate, easily acquired thanks to cert-manager. All traffic is encrypted. All end-user requests are authenticated. Devs don't need to set any of this up, but since they can control the mapping pieces, they can move quickly without breaking things. And devs own what they know best, the app, while a platform team, DevOps, whatever, owns those critical pieces of configuration. I'm going to go back through the Q&A now, and the other piece, the most important critical thing here I'll do is I will share this slide link so that you can go reach those links at the end. This first one is the code, so you can try it out if you want. There's a link to Emissary-ingress's homepage, our homepage, my email here if you want to reach out to me directly, and then my Mastodon and Twitter. I'm on Mastodon more than Twitter, so you need to @ me on Twitter or I don't really look, just so you know. All right, let's talk about Q&A. Let me scroll way back up. You know what? Here, I'm going to stop sharing so I can just bring this in front of me and be looking at you all while I.
Well, and Dave, we can help with some of the questions.
Sure. Yeah.
I know the first one that came up, is there a GitHub link? And I don't know that you just had a.
Yeah, so if they go to the slides at the end, then there is a link to all that code. And again, I tried to do my best. The reason there were some variables in there is because theoretically, and you can reach out to me on social media to correct my problem, my mistakes, but theoretically, people should be able to clone that down, change a couple of configuration settings, and run it in their own environment.
Okay. So I'm going to ask some questions, and if they've been answered, just let me know. Do you use the same certificate root for all layers of Zero Trust, or do you recommend using multiple root certs for different layers of the systems?
I think that Tim's talk is probably going to be the best talk on that, because he's going to talk about generating and distributing trusted certificates. And so I think either Alex or Tim will probably be the best person to answer that in terms of like going down the stack. I think the answer is you should be using different ones. And in fact, I know that you can configure Linkerd to like rotate the certificate every 24 hours if you wanted to. That's the general one. But for this one, that Emissary is using, like we're generating it specifically for Emissary to use as the entry point one.
Okay, so in 1 hour, TJ, come back and ask that question.
Okay. TJ had another question. Will Emissary-ingress support Gateway API that went beta in K8 1.25?
Yeah, so At the moment, we have alpha support for an earlier version of Gateway API. We are focusing a lot of effort now. We're on the steering committee for Envoy Gateway, which is the Envoy spin-off project that is a specific implementation of the Gateway API. And so Emissary is not going anywhere. We're going to be supporting it for a long time. And we're going to probably create tools that allow people to, migrate as they want or need to. I attend the Gateway API meetings every week, and I think that that's, as much as it's there, it's a ways off from being as feature complete as it needs to be for people to really use it for all of the purposes that they can use things like Emissary for now. But that's more where we're going eventually is Envoy Gateway. And that will be a full implementation of the Gateway API plus.
And then there's a question, does Emissary-ingress work well with AWS EKS or Fargate?
I can vouch for EKS because anything that is Kubernetes, it's going to work perfectly fine with. Fargate, Fargate's the on-demand. I'm not as familiar with Fargate. Like when Fargate was a product originally coming out, I remember being excited about it, but I don't remember why now because that was many years ago. As long as it is a Kubernetes environment that you can install things into, because Fargate is just managing the size of the nodes behind the scenes without you having to do that, I believe. Again, anyone is welcome to correct me in the chat. It should work fine. But yeah, anything where you're controlling the install of CRDs and deployments and stuff, it should be fine. I think all Fargate does behind the scenes is manage the physical nodes behind your cluster, so it should be okay.
Okay. And then I think our final question, which will probably link really well to our next talk, is around, can this example work within a service mesh?
Yeah, so the only thing you need to do with Emissary to put it in a mesh is make sure that it has the annotations or labels or whatever required to put it in the mesh. So with Emissary and Linkerd, that is like in the Helm chart for Emissary, you can say add the label linkerd.io/inject true, and it will be in the mesh. Then once we terminate TLS at Emissary, any requests going down, if your pods are in the mesh, now they've got MTLS, and I'm sure Alex will speak much more to that, and I haven't stolen their thunder. So yeah, that's yes, absolutely. And then I think there was one up here. How do you manage secrets used by applications? I just remember that one from looking at it in the middle.
I'm like, I missed that one.
Yeah, so that's a bigger question than today's. I'd love to have that as an extended conversation offline. If you want to reach out to me over social media or email or something. I mean, that's really just down to the larger system, right? I mean, with cert-manager, that's storing secrets in the cluster because that's functionally part of how it does that. If I was storing secrets for the actual application, some deployment pipeline vendors or services or open source systems have ways of doing that, where you can manage the secrets in there and then they get injected into the cluster. What I use personally and for my own personal infrastructure stuff is 1Password because I already use it, and they have a Kubernetes integration. At that nonprofit I was working at, I used a thing called Doppler. But yeah, I mean, there's so many solutions for that, I think, and that honestly is the hardest part of all this to me. Like within this, what I did today, if you go look at the code repo, I have secrets in here, like my Cloudflare, API key that is not part of what's pushed up. It's like kept in like a local configuration file via Pulumi, because I don't want to push that up to GitHub for obvious reasons. But that's always the hard part, is like, how do you do GitOps with secrets? That's and I think like the simplest but worst solution for me personally is using like GPG to encrypt files in the repo or something, and it's that using Git secrets or whatever, that feels like a real nightmare. So and again, that's a longer conversation to have offline.
Awesome. Well, Dave, thank you so much for being here. Thank you for that conversation. I'm going to go lock my front door just to be sure.
Yeah, secure the perimeter.
Yeah. Have a great rest of the day. And we're going to bring in our next speaker.